Hello everyone. So in this video, I'm going to solve the question number 15, which is displayed on the screen. So this question also, some of the students have asked their doubts. That is regarding calculating the voltage regulation. Here it is there, the complete question. So let us begin by once again drawing the circuit diagram. So we have a 20 kVA 1700 by 250 volt single phase transformer. So let's begin by making a single phase transformer. So, so what are the parameters? So 20 kVA 1700 by 250. Okay. So this is 20 kVA 1700 by 250 volts. So 20 kVA is the full load capacity. So resistance and reactance parameters on primary and secondaries. Okay. R1, R2 are given. So let's draw R1, R2. So this is R1 X1, R2 X2. So what are the values? 6 ohms and 0.03 ohms. So this is 6 ohms, 0.03 ohms. Now, if I go up, sorry, I just jumped another page. Okay. So X2, here you can see, let's magnify a little bit. So X2 is 12 and, sorry, X1 is 12 and X2 is 0.11. So this is 12 ohms and 0.11 ohms. So now we need to find the voltage regulation, right? Let's complete the question. The voltage regulation when transformer is supplying full load 0.72 power factor lagging. Okay, so let's show the load also. So there is a load here. So 0.72 power factor lagging, and it is full load. So now, right away, I can find the current. Okay, so how much current will be there for a full load? So the 20 kVA is given, and then the full load, and then all these details are given, so I can find the current. Okay, so here for finding voltage regulation, so what is the formula for voltage regulation? Okay, so voltage regulation is nothing but no load voltage minus full load voltage, so divided by no load voltage into 100. So now to get the percentage value. So now this no load voltage minus full load voltage is nothing but the voltage under no load, that means zero current, because whatever is the, so here this will be the V2 which is under no load, and here let's say V2 dash. Okay, so whatever comes at the terminals. So what is the difference between these two? The drop in the this one. So in fact, there is a voltage drop here also. Both the voltage drops we need to consider. But anyway, we'll transfer this to the other side so it will become easy. Okay. So that is nothing but voltage drop divided by voltage at no load into 100%. Okay. So this is the final answer that I need to calculate. So, but let us first transfer this 6 ohms to the secondary side and 12 ohms also to the secondary side. So what is K? K is V2 by V1. So that is 250 divided by 1700. Okay, so let us calculate that. So I have my calculator. So 250 divided by 1700. So 0.11 147. Okay, let's take that as the value. So what is k square? So let's do k square. So into answer, so 0.02163. Okay, so the round off 0.02163. Okay, so I got the k square. So let me use this place. So what is R naught 2? Total resistance refer to the secondary side. That is nothing but R1 into k square plus R2. Okay, let us do this R1 into k square. That is 6 into this value. So into 6. So 0.1297, right? So I'll round it off to 0.13. So 0.13 plus 0.03. In fact, I think 1297, right? I think it doesn't matter. So I'll make it 0.13 only. So this will be 0.133. So that is R naught 2. What about X naught 2? So I should take this 12, multiply this k square. Okay. So, okay, I'll clear everything. I think I have this feature here. So this is k square. So k square multiplied by 12. So this one. And to this, I will add the x2. X2 is 0.11. Okay, so if I see here, x2 is 0.11. So that also I will add plus 0.11. So it's 3695. So yeah, so I'll make it 37.37. So I got R naught 2 and X naught 2. Okay, so because the drawing is becoming big, so I'll just make a simple diagram. Now on the primary side, nothing is there. The entire R naught 2 and X naught 2 are here. And then I'm getting the terminal voltage V2, and here the V2. Okay, let's call it V2T. And then there is a load of power factor. So full load 0.72 lag. Now what are these values? So these values are 133 and 37. And remember this reactance will have J. So now assume that we are applying a rated 1700 volts, and I will be getting 250 volts, right? Is that what was the rating? Yeah. So 1700 by 250. So already the no load voltage I know it is 250 volt. Now I need to find the voltage drop. For that I need to find the current. Okay. So what is the current? So the current is nothing but current at full load is nothing but whatever is a kVA rating. Okay, so the kVA rating was 20 kVA. Okay, so 20 kVA or 20,000 VA. So divided by 250 V, because this voltage is 250. So the volts will get cancelled, and I think this will be 8, 80, 80 amperes. 20 kVA divided by, yeah. So now I got this current to be 80 amperes. Now it helps if you make a small vector diagram. Let's make some place here. See, I'll consider this as a vector representing V2. Okay. So that is nothing but 250 at angle 0 degrees. I'm using this voltage 2 as a reference. If this is a reference, then this 80 amperes current will be lagging. Okay, so what is the phi here? Phi is cos inverse of 0.72. Okay, how much is that? So, so here there is an inverse function. So inverse of cos inverse of 0.72. So I'll get angle as 43.94 degrees. Okay, or I'll round off to 44 degrees. See here there is a degree and radian. So be careful. It should be in degrees. So whatever answer you are getting, that is in degrees. So 44 degrees is the angle. And this is my I full load or I2 full load. Now, whatever drop here it happens, I2 into R, that IR drop will be in phase with the current because the resistance it is like this. So here I will get a line like this. So this is voltage in the R. So voltage in the R and current in the R will be in phase. Okay, so like that. Okay, let's call this as voltage in the R. And voltage in the X will be 90 degrees leading that. Okay, so it will be something like this. Voltage in the X will be 90 degrees leading the voltage in the R because here it is like that. So now if I make a horizontal line and drop a vertical line just like this, so here this length, so let's say A, B, C, D and E. So the length AB is nothing but VR into cos of 44 degrees. Okay, so that length AB is like that. And BC is nothing but same as this one. So let's call this F. So this angle is 44 degrees. I'm sorry, not this angle. This angle will be 44 degrees. So the opposite of this will be this DF, which is equal to BC. Okay, so which is nothing but the Vx hypotenuse multiplied by sine of 44. Okay, so finally the what is the voltage drop? Voltage drop is V2 plus VR. See, if I take these two voltages, if I add these two voltages, that will be the voltage drop. Okay, so like that. So how do I get the voltage drop? So simply I'll multiply. So let me write the formula here and I will do the calculation later. So voltage drop is nothing but these two. Okay, that is uh, I full load is common. Okay, R naught to cos phi plus X naught to sin phi. Okay, so anyway, these formulas and all I might have derived in another videos in the playlist, but just for your benefit, I just redid the formula. So this is the calculation we need to do. So this, so now let me write it down. So V drop is nothing but I full load current into R naught to cos phi plus X naught to sin phi. So now, what are the values? So this is 80 multiplied by what is R naught to 0.133 into cos of 44 degrees plus 0.37 into sine of 44 degrees. So this will be my final answer. So let's calculate it. So cos of 44, that should be 0.72 already. So already given. So I'll directly use 0.72 and multiply it with 0.133. So 0.9. So I'll directly multiply it by 80 also so that it will be so 7.661. So this first term is 7.661 plus now again the 80 will multiply here also. So sine of 44. So it's already in degrees. So make sure that your thing is in degrees here. Then sine of 44 multiplied by, okay, so I have to say equal to, multiplied by 0.37 multiplied by 80. So 20.562. So finally my voltage drop comes to 7661, right? So plus this one equal to, so 28.22. So this is the voltage drop. Okay, now percentage regulation is nothing but 28.22 divided by 250. That is my uh, no load voltage, right? So divide by 250 multiplied by 100. So 11.29 is my rounded answer. So 11 point percentage. Okay, so this is my voltage regulation. So this should be the final answer. So let's check. Okay, so 11.887 is coming close enough. So I'll probably go with option B as the correct answer. Just a minute. So I just confirmed. So here B is the final answer. I hope this video helps you. Thank you.